Theoretical approach to probability. In this module, you will learn about the theoretical approach to probability. In our day-to-day life, we encounter many situations like Rahul's possibility of joining politics, India having good chances of winning a match, Neelam clearing a job interview, etc. These chances of occurrence of a particular event are called probability. The theory of probability can be studied by using two different approaches. One is the experimental approach and the second one is the theoretical approach. The experimental approach to probability depends upon the actual experiments and adequate recordings of the occurrence of certain events. For example, you are playing cards with your friend. Now, you have started shuffling the cards. Can you predict the consequence or the outcome whether the card laid on the top will be red or black when the cards are still being shuffled? No, that is not possible. In this particular situation, shuffling the cards in terms of probability is known as an experiment. This experiment is a random experiment as is unknown. Therefore, the experiments which do not have a fixed result are known as random experiments. Whereas, the theoretical approach to probability attempts to predict the happening based upon the total number of possible outcomes. If you notice, you'll find that the experimental probability of an event actually approaches to its theoretical probability if the number of trials of an experiment is very large and time-consuming. Can you give a strong reason why we need to use the theoretical approach to find the probability of an event when real-life experiment can be conducted? Yes, in many cases, conducting a large number of experiments is either expensive or not achievable. On shuffling cards, the experiment of drawing a card from a deck of cards could be repeated a huge number of times to get a better result. But in the other situations, for example, we are interested to find the probability of failure of a satellite launch. This experiment cannot be conducted multiple times as launching a satellite a number of times using rockets, and it is neither feasible nor practical. Similarly, the repetition of the phenomenon of an earthquake to compute the experimental probability of a multi-storied building getting destroyed in an earthquake is not possible. So in such cases, it becomes tough to make certain assumptions, and based on such assumptions, the theoretical probability is calculated. Thus, in experiments where we are prepared to make certain assumptions, the repetition of an experiment can be avoided as these assumptions help in directly calculating the exact theoretical probability. The theoretical probability is also called classical probability. Thus, the theoretical probability of an event, say E, which is written as PE, is defined as PE is equal to the number of outcomes favorable to E upon the number of all possible outcomes of the experiment. A coin is tossed on an 8x8 standard chessboard. What is the theoretical probability that the coin lands on a white square? There are 32 black squares and 32 white squares. Let E be the event that a coin lands on a white square. The total number of possible outcomes is 64, where there are 32 white and 32 black squares in total on a chessboard. As we know, finding the theoretical probability of an event is equal to number of outcomes favorable to E upon the number of all possible outcomes of the experiment. Then the probability of an event is 32 upon 64, that is equal to 1 upon 2, and in decimals, it can be represented as 0.5. Thus, the theoretical probability of a coin landing on a white square is 1 upon 2 or 0.5.
Let's recap. The experimental approach to probability depends upon the actual experiments and adequate recordings of the occurrence of certain events. The theoretical approach to probability attempts to predict what will happen, which is based upon the total number of possible outcomes. There are many more examples where the theoretical approach will be a better option to find the probability. Like many consumer products, such as automobiles and consumer electronics, use reliability theory in the product design to reduce the probability of failure. The failure probability may influence a manufacturer's decision on a product's warranty, weather forecasting, if it will rain or not,